Hi, I'm Tyler Fultz. I'm a nuclear engineer with a little over 10 years of experience in the commercial nuclear power industry, from engineering to operations to emergency response. I don't claim to know everything there is nuclear, but I can certainly share some knowledge. Today we're going to be looking at a video called What If You Detonated a Nuclear Bomb in the Marianas Trench by Ridddle with 3 Ds. This one was recommended to me, and I've heard this one has all kinds of issues with it. Let's check it out.
What would happen if a nuke went off in the Mariana Trench? This is the Tsar Bomba, the nuke that Soviet leader Nikita Khrushchev promised to show the West during the Cold War.
Alright, so we're going all in. This is the biggest nuclear weapon that was ever designed.
58.6 megatons of sheer, unadulterated power with
58.6 megatons. Okay, so the one that was actually tested was at 50 megatons, but I do recognize the number 58.6, and that is what we believed the yield of the bomb to be until documents were declassified back in 1991. Now, that's not technically wrong, because it had a design range of anywhere between 50 and 100 megatons, but if you were to test the 100 megatons, they were concerned that the bomber would be able to escape the blast radius of the device that was that powerful. So they actually scaled it down just so they can do a test. But yeah, this bomb, 4,000 times more powerful than the bomb that was used over Hiroshima, and completely impractical. The device itself weighed 27 tons. And you couldn't mount it on a rocket or an ICBM. Here's how they actually had to carry it. This right here is the Tupolev 95 bomber, NATO's signature bear. It was the Soviets' largest strategic bomber at the time, and look how big that bomb is. They couldn't even keep the bomb doors closed while it was carrying it. This fat, juicy radar signature would be an easy target for interceptors. In addition, they actually gave the bomb a parachute to allow the pilots to escape the blast radius. Here's what the real explosion looked like. The bomb was detonated at an altitude of 4 kilometers, and this mushroom cloud right here was 60 kilometers high. Here's another way of looking at it at the actual site. Yeah, a village was leveled 55 kilometers from ground zero. Modern nuclear weapons are typically much weaker, on the order of 500 kilotons.
Subsequent blast wave that circled the globe 3 times, and this is the Mariana Trench, the deepest crack in the Earth's
The 3 times part is right.
surface and completely filled with water. The Tsar Bomba was
You would have to, the bomb would be crushed under the intense pressure, so nothing will happen.
all right. So we've decided to blow up the Mariana Trench. Before answering the question, what happens,
It wouldn't actually blow it up.
we have to figure out a method for delivering the bomb to a depth of 7 miles or 11 kilometers.
I mean, the Mariana
And it's
Trench
not
is massive.
as simple as you might think. After all, the density of water is 1 gram per cubic centimeter, which means that at these depths, the water pressure will reach 110 megapascals, which is 1,100 times normal atmospheric pressure.
They said 110 megapascals, but it's showing 110 million megapascals on the screen. Okay.
For our lackluster end result would be a giant uranium pancake, 130 feet or 40 meters in diameter, ending up at the bottom of the Mariana Trench.
Mentioned uranium. Uranium's not even the primary ingredient here in it, because this is a thermonuclear weapon or a fusion weapon. Lithium deuteride's the thing that gives it most of its kick.
This pancake will emit radiation for centuries, as the half-life of uranium is 2,000 years.
No, it's not. The half-life of uranium-238, which was actually used in this weapon, is 4.5 billion years, or roughly the same age as the Earth. Even uranium-235, which is used in other weapon types as well as nuclear power plants, its half-life is 700 million years. No idea where the 2000 is coming from. Alright, let's talk about how this weapon really works. Tsar Bomba is primarily a thermonuclear or nuclear fusion weapon, so uranium isn't even the main ingredient. This device is essentially 3 bombs in one, because in order to create fusion in the bomb, a primary fission stage is used to generate enough heat to induce fusion. Fusion requires temperatures of over 100 million degrees Celsius. First, conventional explosives are used to trigger the neutron source in order to trigger nuclear fission in plutonium-239. Plutonium-239 is far more reactive than uranium-238 in its fission reaction. This fission reaction creates conditions hot enough for this deuterium-tritium gas to induce fusion. All of this energy and heat then moves after that stage into its final stage on the fusion device. Tsar Bomba used 50 kilograms of lithium-6 deuteride, or the fusion fuel, to generate most of the yield. Uranium-238 was really only used as a tamper to increase efficiency. Think of it as a fuel additive for your car, which can be varied to alter the yield of the weapon. During the test, Tsar Bomba actually had a lead case rather than a uranium-238 case, which was one of the factors to lower the yield from 100 megatons to 50 megatons in the test. This entire process of chemical explosive to fission bomb to fusion bomb, all of this right here took less than 1 microsecond.
In this scenario, there will be no explosion. The charge won't be compressed to the point of critical mass, and the thermonuclear shell of the bomb will get torn off halfway to the bottom and dissolve in water. So let's say the bomb will be...
Okay, at least they got that it wouldn't actually detonate.
We're down inside a bathyscaphe. That's a deep-sea submersible designed to withstand high pressure.
That submersible isn't big enough. You would need a full-size submarine. Again, the thing weighs 27 tons.
Optionally be remotely controlled. In this case, we're gonna get our bang. And there's actually more than one way for that to happen. One, if the bomb is detonated at a depth of between 3 to 5 miles, that's 5 to 8 kilometers, the explosion...
So a bit of historical context here. The deepest bomb was actually at about 2,000 feet, or less than half a mile, that was detonated underwater. This is the explosion from it. It was relatively small, about 30 kiloton, or over 1,000 times less yield, but this one didn't have nearly as much water above it, and the water is exerting so much force on that. Pressure rises by 1 atmosphere every 30 feet you go underwater. So this is going to be competing against so much force. 50 megatons is impressive, but they don't... It's really not going to do very much.
Won't be that much different from your typical underwater nuclear test. Oh, except...
No, it will. That is very deep. Nothing has ever been detonated that low.
For a tsunami 400 feet or 122 meters high that will appear on the surface of the Pacific Ocean and completely wash away Japan and all of South.
What? 400 feet? Okay, you're not going to get a 400-foot wave. So first off, let's make this crazy scenario even whatever. A 50 megaton nuclear weapon, that energy is equivalent to 8.1 on the Richter scale. Or 8.3 if you want to use a 100 megaton nuclear bomb. Let's go ahead and highball this as much as we can. And let's say that energy was... Let's say it was like right at the bottom somehow, and all that energy went into that Mariana Trench, into that tectonic plate, and let's just say it caused an 8.3 earthquake. They don't generate tsunamis that high. We're talking maybe 50 feet. Something like that. And that's not unheard of to have an earthquake like that. I mean, earthquakes on the order of 8, you have a few of those per year kind of thing, depending on where they're at exactly. And that's still assuming that all that energy went down into the earth and none of it got hit by the water. So even your worst case scenario, you're not dealing with 400 feet. And did he say hit Japan? Japan is mountainous. 400 feet. Japan got hit with a 50-foot tsunami back in 2011, and it didn't wipe out Japan.
Asia. Also, half of Australia and the eastern regions of China
Come
will
on.
see tremendous flooding. And the U.S. Pacific coast, especially San Francisco and Los Angeles, will be...
No, just no. It doesn't. It wouldn't have anywhere close to that range, even if the Mariana Trench had an 8.3 earthquake. If it had a 9.0 earthquake, it wouldn't do this, and tsunami. No, let alone a little, setting off a little bomb in there. It's a little bomb compared to the strength of plate tectonics.
Besieged with waves up to 250 feet or 76 meters. Other corners
Where are they getting these numbers from?
Too, albeit somewhat milder, relatively speaking. Also, the background radiation in the Pacific will rise slightly for a few days before going back to normal.
That's the only part they sort of got right. Yes, some of that will rise to the surface. The more of it will depend on how higher up the trench it's detonated. More of it will reach the surface, but we're talking a very small amount of radioactivity compared to a surface test or an airburst test in the case of the real Sarbama.
If the bomb is detonated at a depth of between 5 to 7 miles or 8 to 11 kilometers, or at the very bottom,
again, nothing's going to happen.
Take into account the fact that the Mariana Depression is located at the boundary between two tectonic plates, the Pacific and the Filipino. If the world's most powerful nuclear device is set off at this spot...
All right, how big do you think the earthquake's going to be? Is it going to be, 8.1, 8.3 kind of range, the yield of the weapon, or is he going to say something completely outlandish? Taking all bets now.
The shock wave from the blast, reinforced by the hydrostatic effect, will produce a tremendous downward force precisely at the location of one of the litho...
Reinforced by the hydrostatic effect. The effects of water will work against this force, not trigger something bigger. Come on.
Atmospheric weak spots, the junction of tectonic plates. As a result, the plates will start either converging or diverging very quickly, and either option spells trouble for humankind. So, if the bomb explodes at or near the bottom, we're not going to...
The weapon's not powerful enough to do that. Like I said, even if it translated all of its energy, yeah, we're talking,
away with just a really big splash. The energy received at the base will be transferred to the boundaries of the tectonic plates at the speed of sound. Part of that energy will be reflected back up from the bottom of the trench to be liberated at the surface in the form of a colossal ultra-super tsunami. Only this time, the tsunami will be just the tip of the proverbial iceberg.
How big does he say it's going to be?
Next, we'll see massive magnitude 12 earthquakes occur across the entire...
Magnitude 12! Magnitude 12. No. That amount of energy, you're getting into cataclysmic asteroid impacts. Magnitude 12, hold on, give me a sec. Let me pull up my calculator. That's 15 million megatons. No earthquake has ever been above a 10. No. Where is he getting this energy from?
Ring of fire, which will then give rise to a second installment of mega uber tsunamis, even
Mega
higher than
uber
before.
tsunamis.
We'll next be treated to a gargantuan release of magma back at the area of the explosion. And this will set
Is this
up
the
a
plot to
chain
the
of
2012 movie?
eruptions to complete the picture, lest the survivors in the highlands assume they've been given a lucky break. This volcanic activity will continue for at least a...
I like how deadpan their narrator is, and I wonder how many takes it took, considering him saying how many crazy stuff this is. They got a good narrator.
So expect the Earth to be assaulted with seemingly endless acid rain, while the airborne ash will interfere with air travel needed for humanitarian missions, in addition to blocking out much of the light from the sun. To me, that smells an awful lot like nuclear winter, or at the very least, a couple of...
Oh, God. So the science behind real nuclear winter is complicated, and there's so many factors that can be affected, but I can say with 100% confidence, it will not be caused by a subsurface detonation of a mere 50 megatons.
Years. Coupled with the tsunamis, the cold spell may result in globe-spanning catastrophe, with many species, including humans, ending up on the brink of extinction.
I mean, the magnitude 12 by itself.
There's also the possibility that a Tsar Bomba-type explosion at a depth of roughly 1.5 miles or 2.5 kilometers from the bottom of the Mariana Trench could punch a hole in the Earth's crust, sufficient to produce a magma fountain.
Magma fountain.
Would then form a new continent, while also bringing about the same tsunamis and environmental problems previously discussed. In addition, the tremendous impact could push the planet very slightly out of its current orbit. This will either bring us closer to the sun.
Oh, okay. Wow, they're trying to do with all the tropes. Out of its orbit, what are they going to say? Knock it into the sun. Are they going to have the Earth collapse into a black hole or something? I mean, come on. Where are they getting all this energy from? The amount of energy to move the Earth. I did a video on this about Earth destruction caused by nuclear weapons. I'm going to go ahead and link that one.
Where we'll thoroughly fry, with dear old Earth turning into something like a second Venus.
In case you're wondering, the spoiler to that video is no, they don't actually destroy the Earth.
Or, on the contrary, the impact might move our orbit further out, where we would descend into a kind of permanent winter. Finally, there's the possibility that so powerful an explosion at the location of a tectonic fault will simply tear the planet itself apart. The fate of humankind in that...
There you go. That was my answer. That was my video right there. Can it do that? No, it can't. No.
Scenario is easy to see.
By the way, that would take many, many trillions of megatons to pull that off. So it would even take a lot of magnitude 12 earthquakes to get you there.
Fortunately, however, the likelihood of any of the above happening is extremely low. As experienced...
The likelihood of any of the above happening is non-existent because that's how physics works.
In the end, humans are no fools. Shortly after the successful atmospheric test of the Tsar Bomba in 1963, the nuclear club countries signed in Moscow a treaty banning nuclear weapons tests in the atmosphere, in outer space, or underwater, a safeguard of sorts to prevent future catastrophes.
Oh my, is he seriously implying that that testing treaty was so that you won't shatter the planet by putting a bomb in one of Earth's magical weak spots? The Earth doesn't have any weak spots like that, by the way. And, oh man, so much wrong with that. And they even downplayed the yield they could have used to hyperscale this Tsar Bomba. They could have said it was 100 megatons and technically not have been wrong. But man, between the them saying that it'll magically shatter the Earth and causing waves, and Japan would be submerged by a 400-foot wave, I don't know where these guys are getting their numbers from at all. Let me know if you have any ideas down in the comments section. Also, be sure to point out what I missed in this video in the comments as far as what they got wrong, because there was a lot I probably glossed over, so please let me know. Thank you very much for watching. I'll see you next time.